All right, so this is our last and final unit, Human Ecology. So it's just, we're piggybacking on ecology. So human ecology is going to look at the human impact on the environment. So here's our warm-up. That's my dog. We're going to try to understand the impact of human activity, both pro and con, good and bad, on the environment. So the first question I'm going to ask is, do humans positively or negatively impact the biosphere, the planet Earth? Explain. So hit pause now and answer that question. All right, hopefully you did that. And then I wanted you to see if this picture, sad planet Earth, influenced your decision or not. You can explain why. So hopefully by now you watched the pale blue dot. If you can, write an essay comparing that to the philosophy you found in Thinking Like a Mountain. Are they the same? Are they different? One's about the galaxy and the other one's about an ecosystem. All right, so let's hop into this. Population growth. Well, when our population grows, and we're talking about human population, we have an overconsumption of resources, right? We need things. You eat, you sit in a chair, you live somewhere that is a shelter. Well, that had to be built with something, so that's resources. Whether we like it or not, we pollute, right? If you threw something in the garbage can today, you're adding to pollution. We overdevelop land as our population grows because we have to live somewhere, right? Think of New York City. That used to be an island of trees. So Washington Heights is called Washington Heights because when George Washington was president, the first capital was in New York. He used to go on horseback rides in Washington Heights, which is now very close to Harlem. So it's the northern part of Manhattan. Deforestation, we have to cut down trees to build things. And we overharvest. We're doing it to our seas right now. And even though we now have bag limits for hunting, in the past we didn't, which had caused overhunting. And then finally, one of the worst things that we do is an introduction of foreign species. So if you look out the window and you see a sparrow, the odds are pretty good that's a European sparrow. Those big flocks of starlings. Starlings are European as well. So we'll get into that. Not in this lecture, but in next. So we'll probably just get into the first couple of topics. So let's look at overconsumption. Basically, as our population increases, it depletes the Earth's resources. We have two types of resources, renewable and non-renewable. So renewable resources are water, solar, wind, firewood, believe it or not, because we can grow trees, plants, or any type of wood, plants, animals. So we can, when we use them, we could reuse them or replant them. Or solar, it's going to be there for a while, and wind. Water we could use for hydropower, etc. Non-renewable resources are fossil fuels such as coal, oil and gas, minerals like iron, aluminum, tin, copper. That's why these things sometimes fluctuate in price, because they're valuable, because once we use them all up, they're all gone. So pollution is caused by burning fossil fuels. It has an excess of carbon dioxide into the atmosphere. It releases dirty black soot into the environment, right? If you think about the spotted moth, on how the numbers of black spotted moths increased in England when the Industrial Revolution kicked in because of the dirty black soot. Now we're trying to cut stuff back down, but we still have pollution, not as bad as it was. My in-laws got engaged on the first Earth Day ever. And my mother-in-law was telling me a story on how they were outside eating ice cream in Manhattan to celebrate their engagement. They do the ice cream thing a lot, and she thought she got the really expensive vanilla ice cream, you know, the kind with the little vanilla nuts and it's like little black speckles. That's kind of my favorite. However, once she dug in, the vanilla ice cream on the inside didn't have the little black speckles, which she realized at that time the little black speckles were the pollution from the air in New York City while they were sitting outside enjoying their ice cream. So things have improved in New York City since then, thankfully, but not in all cities across the nation and across the globe. So what does pollution cause? Global warming, which we'll get into in acid rain, two different things. Just this is probably in the wrong place, but fossil fuels are fuels that are not from fossils. The things that give us our fuel today, like the plants and stuff that died 300 million years ago, the things that lived when those plants lived are fossils today. So that's where the term fossil fuel comes from. So burning fossil fuels releases greenhouse gases, particularly causing acid rain and global warming. But we use them to power things every day, right? It's kind of really hard not to use energy. So what is global warming? Well, what happens is our planet is radiated by the sun, but with the CO2 that rises, it then doesn't allow some of the sun to release at night. So let me give you an example. When I lived in Southern California, it could be like 110 degrees during the day, but Burbank, California was originally a desert. So the only reason stuff grows there is they actually get their water from Northern California and the Colorado River. So there's not a lot of tree cover. So at night, it would get down to like 65, 70 degrees because the heat would escape. Well, with global warming, the heat can't escape because we have the CO2 layer kind of blocking it in. So it traps the heat around the Earth and therefore raises the temperature. And you don't have to raise the temperature a lot for it to be dangerous. I always talk about in class the big danger of CO2, excess CO2, is it's absorbed in the oceans. And our photoplankton, it has a very thin shell of calcium carbonate. And if you remember from maybe an experiment in Ms. Husky's class on how you put an egg into vinegar, which is acid, that's the same covering that our photoplankton have that give us a lot of our oxygen, etc. So in our coral, in the start of the food chain, etc. So when water absorbs carbon dioxide, it becomes acidic. That's why Coca-Cola or any type of soda that has carbonated water in it is slightly acidic. It will say carbonic acid on it, but it's just carbon dioxide in water makes water acidic. So this is why we call it the greenhouse effect, because it has a similar effect as a cover on a greenhouse. Here's just another picture of kind of what's happening is the heat can't escape. Here's the change of CO2 from the 1960s to now. If you look at it, it seems like a lot actually, right? But if you look at the graph, it's going up by parts per million. So we're looking at the numbers 310, 320, 330. But it's actually parts per million. So for every million parts, you only have 310. So if this was a fraction, it would be 310 over a million. Still a lot. But you could also argue the other side. So here's how things have kind of flipped, if you look. So our global temperatures compared to our rise in carbon dioxide. So the blue is where we want to be. The red is where we don't want to be. There was an influx in the 1940s. Kind of figure out what was going on around then. Okay. And there's natural cycles as well, and we'll talk about those natural cycles of heating and warming. But if you look from pretty much the 1980s on, there has been no cooling of the planet at all. So I grew up in the 80s, and there were some massive snowstorms. So when these blue temperatures hit, people were saying that the next ice age is coming. And people will always send you back to those times and say, oh, don't worry about global warming. But they only talked about it for a short period of time. Look at this long black line. Now, again, look at these numbers. All right. So 0.5 degrees. So the increase has been 1 degree Fahrenheit, which is a little bit more than 2 degrees Celsius. If we had time, we would watch this debate. I'll post it on Google Classroom. I'll explain a little bit of what it says. I'm not picking a side politically, but this is a graph that was shown in this debate. So here's kind of what's interesting is that the politician just shows the graph from like 1998 to the present. And the scientist shows the graph from 1970s to the present. So what they're trying to explain is there are these environmental cycles that kick in called El Nino. It means the child. So it usually happens around December in the Pacific. It becomes really, really hot. So if you think about it, people who actually settled the West Coast were Spaniards. So most of the terms and stuff that would come from the culture on the West Coast would be in Spanish, right? If you lived in California, like Los Angeles, San Francisco, right? Those are all Spanish names. We tend to forget that when we live on the East Coast. So in December, about every 20 years, there would be what was called an El Nino. So when I was in Alaska, I experienced an El Nino year. It gets freakishly hot, the waters. So what they're trying to argue is that those rise so the politician will say, well, if you look, the temperatures have crashed since 1998. And they've crashed again since 2010. And he's right when you just show that small little section, this section here. But the reason that they crashed was there was that normal cycle of El Nino. So that's why the temperatures from 1998 to the present, you could argue, have lowered. See, that's how kind of people take science and kind of manipulate it. However, if you go back to 1970, that those were freakishly cold years. So where we want to be is kind of at this line right here. So this is a bad place to be. We want to get down to here. All right. So let's wrap this up. In order to reduce consumption of non-renewable resources, humans could do what? A, burn coal, heat our houses instead of oil, heat household water with solar radiation, increased industrialization, or use a natural gas grill for barbecue instead of charcoal. Well, if you picked B, you were correct. Right? I hope that was helpful, and I'll talk to you tomorrow.